For this example, we will now be using trigonometric functions for Laplace transformation. We will show that the Laplace of cosine bt is equals to s over s squared plus b. From 0 to infinity, cosine b t times e is negative st dt. By using integration by parts, our u is cosine bt and our du is negative b sine bt dt. Our du dv is e raised to negative st dt and our v is negative 1 over s e raised to negative st. Now substitute. Our u is cosine bt times v negative s e raised to negative st, limits 0 to a with a very large number minus the integral of v negative 1 over s times e negative st, and our du is b sine bt dt. And with mentally calculating this part of the equation, we can assume that with a substitute as a very large number into a e raised to negative s times a, it is 0, plus because minus times minus is positive and cosine of 0 is 1. So we have 1 over s minus, and our constant is negative b all over negative 1 over s, and we multiply it with negative times negative is positive and times negative is negative. So b over s with integrals of, and what's left is sine bt times e, so negative st dt. This, and we cannot find a specific solution, so just continue using integration by parts with our u as sine bt and our du is b cosine bt dt. Our dv is e raised to negative st dt, and our v, as usual, is negative 1 over s e raised to negative st. And substitute again with 1 minus b s times, with the integrals of this by integration by parts, we have u sine bt all over v is negative s e negative st, limits 0 to a with a very large number minus integrals of negative 1 over s e, so negative s t, and our du is b cosine bt dt. Now, by mentally solving this, as by substituting both of these limits, we can say that with a substituted into e raised to negative s times a, just like before, it is 0 minus negative sine b times 0. Sine 0 is 0, so we can already omit this part of the equation, 0, and now we can just pull out the constant for this part of the equation, and our constant is b times negative 1 over s. So we have negative b over s times negative is positive 1 over s minus b over s times positive b over s. b over s integrals of, and what's left is cosine bt e raised to negative st dt, and we multiply it. 1 over s minus b squared over s squared integral of cosine bt e raised to negative st dt. With this, we haven't arrived even with a simplified solution or answer, and we need to again use integration by parts. But integration by parts. So that we can arrive with a solution or the answer, we will need to use the complete solution of integration by parts as integration of u, v, or dv is equals to uv minus integrals of v du. So we substitute it. Our integral of u dv is this. Cosine bt e raised to negative st dt is equals to our u here. This part of the equation represents this 1 over s minus b over b squared over s squared integral of cosine b of t e raised to negative st dt. We substitute this part into this part of the equation, so because they have like terms of this integration, so and then we factor out, and what's become of the equation is 1 plus b squared over s squared integral of cosine bt e raised to negative st is equal to 1 over s from limits 0 to a with a very large number. So, or we can just use infinity here. So we can say that integral of cosine bt times e raised to negative st is equals to 1 over s all over this one 1 plus b squared over s squared. So, the integral of cosine times b times t times e raised to negative sp is the same as this. So we can make this, and we can say that this is like the Laplace of cosine bt. So the Laplace of cosine bt is equals to this 1 over s 1 plus b squared over s squared. With this solution or answer, we can still simplify it. Our simplified answer is 1 over s squared plus b squared to multiply s squared over s times s squared plus b squared, cancel s over s squared plus b squared. There. That is how we arrive the Laplace of cosine bt is equals to s over s squared plus b squared.